e chiederei a Hagen Lehmann se intanto può cominciare a prepararsi per la sua presentazione.
Buongiorno.
Hagen Lehmann ci presenterà un intervento su Social Robotics in Enactive Didactics, Initiating Self-Reflection in Students. L'abstract in inglese, chiedo se la presentazione credo sarà in italiano.
No, anche in inglese.
Anche in inglese, va bene.
Okay. So, buongiorno and good morning, everyone. My name is Hagen. I'm a researcher at the University of Macerata, and in this talk I will introduce a long-term study doing the Pepper robot being used as a social mediator during university lectures. The talk will have two parts. In the first part, I will give a brief overview of the background on which our work is based, and in the second part, I will introduce our actual study and the implications of our results on, or the possible implication of our results on educational child-robot interaction. So let's start with some background information specifically concerning social robots. In order to understand what we mean by social robots or robots in the function of social mediators, it is necessary to look briefly into the history of embodied artificial intelligence. Embodied AI started in the late 80s with protagonists like Rodney Brooks, Luke Steels, and Dorothy Pfeiffer as a reaction to the crisis of the traditional AI, which saw intelligence as a set of rational capabilities. Embodied AI, on the other hand, acknowledged that biological human cognition includes, besides these rational capabilities, processes that are deeply connected to the body, like actions, intentions, and emotions, and that cognition arises from the body through sensory motor associations and is not necessarily mediated by representations. So intelligent artifacts moved from being computer programs to complete agents with a body, which are robots, basically. And the idea was that robots needed to interact with and manipulate their environment to develop high-level cognitive skills, and therefore embodied AI research aimed at modeling basic capabilities like movements and actions in robots, and in this way, trying to make higher cognitive functions, higher level abilities emerge. However, because of this, with the rise of embodiment and of embodied agents like robots, also the social dimension of interaction became important, because a body enables these complete artificial agents or robots to interact naturalistically with their human counterparts. And with these ideas from human social evolution started to become interesting for robotics research. From the beginning of the 90s, one specific aspect of human intelligence, social intelligence, became the focus of robotics. And with this shift of focus, the research field of social robotics was created by protagonists like Cynthia Brazil or Kerstin Doudna. And according to them, in order for robots to be considered social robots, they need to be socially evocative, socially situated, sociable, intelligent, and acceptable. These social robots are aimed to work in close physical proximity with humans, and by that generate mixed human-robot ecologies. There are a lot of possibilities social robots can look like and what their abilities can be. They can provide emotional comfort, help with cognitive problems, connect family members, or help children, for example, to learn new languages. And in most of these cases, the robot functions a social mediator that facilitates interaction between different humans. Some of the fields in which we are finding such robots are, for example, home companions. They help to counter the effects of loneliness or mediate, as we just said, human-human interaction, but also in entertainment robots, these artifacts fulfill these functions. They can be found in robot-assisted therapy, where the robots help to change behaviors, feelings, and attitudes of humans, for example, with disabilities. Specifically here, a field where robots were employed quite successfully are for children with autism spectrum disorder or ADHD. And of course, robots are used in education and STEAM education, or increasingly more and more as social mediators between teachers and students. And the latter is being the foremost interesting and relevant for our application. Since these robots need to communicate and interact successfully with humans in complex social environments in an intuitive, flexible, and pleasant way, we are facing a variety of challenges still in this field. We still have inappropriate feedback from the robot towards the reactions of the humans. We have perception issues. The robots need to identify their humans, the humans they interact with, their goals, preferably also their intentions and even their emotional states, and behave accordingly. And the communication between the robot and the human needs to be multimodal, and all aspects of these interactions, all aspects of this communication between the humans and the robots need to be synchronized. So these are all issues we still have, and why we are not seeing the robots, humanoid robots as social mediators deployed on a large scale in the classroom yet. Okay, so let us now have a look at the theoretical approach that we are using for the implementation of our robot into schools and universities. We are using an active approach to didactics, and this approach sees learning, sees the learning situation as a complex multi-dimensional system in which every interaction between its different parts changes, not only the dynamics, but also the parts that are involved. Enactive Didactics is based on the enactive approach to cognition, which is inherently interdisciplinary and has its roots in early cybernetics research by, for example, McCulloch and Wiener, but also in radical constructivism by Heinz von Förster, or the autopoietic cognitive biology approach by Maturana and Varela. The enactive approach to cognition was formulated by Varela, Thompson, and Roche in their book, The Embodied Mind. And being interdisciplinary, of course, has influences from many different fields, for example, from the cognitive sciences, psychology, and philosophy. One key point of the enactive approach to cognition is that it discards the distinction between internal and external factors influencing the development of a system that exists in an environment. It replaces this distinction with the concept of structural coupling between the system and its environment. This structural coupling is defined as a continuous mutual process that co-transforms the patterns of activity of a system and its environment. Through the expression of reactions intended to maintain or re-establish internal equilibria, the individual changes its environment and the process in which it interacts with it. In this way, the system and the environment need to be thought of as two aspects of the same process. Applied to enactive didactics, this means that this perspective focuses on the interactions between teachers and students in the process of creating knowledge. The central role of the teacher in this approach is to raise the awareness of a problem in the student having done this, it becomes possible in the next step to find an answer together. The way in which this answer is constructed is determined by the teacher, who acts as a mediator between the world experienced by the student and the knowledge to be transmitted. This process serves to activate conflict in the student that connects the student knowledge with the new problem and the related new knowledge. The crucial phase is the validation of this constructed knowledge. So this feedback about the progress of the learning cycle is very important, because in absence of feedback, closed system and self-referentiality. Unfortunately, one of the limitations of many interactive processes is the lack of space for interaction and feedback, as we know from teaching situations. And we believe that the presence of an enforced, embodied feedback channel in form of a social robot could become a fundamental support for learning processes. What enables us to have social robots a central role in the learning process are their unique properties within the social exchange process. Because they have a body equipped with sensors and effectors, they can react to their environment, and the expression of their reaction depends on how we want them to be interpreted. They need a certain degree of continuity in order to be meaningful, but beyond this, the expressivity depends strongly on the aim of the context in which they are used. Okay, so this was a bit of background information, why and how we construct our applications with our robots. And the second half of the talk now will be dedicated to our actual study and the potential implications of our findings for educational child-robot interaction. For our study, we used the Pepper robot. Pepper is a semi-humanoid robot with multimodal interaction capabilities. It has an interactive tablet, many different sensors. For example, it has tactile sensors on the head and on the back of the hand. It has cameras, it has a sonar sensor, it can move, it has a lot of activators, it can move its hands, has many degrees of freedom, which make it possible for the robot to express gestures, use gaze, head gaze, in order to engage with the human counterpart. So it's a very expressive robot, and this is specifically interesting for the way we want to use the robot in our application. During our study, the robot had two main functionalities. The first and the most important function was the strengthening of the feedback about the progress of the learning cycle, which we saw is very important in the learning process between the professor and the students concerning the content of the lesson. And the second function was the robot provided structural feedback during the ongoing lesson, helping the professor to improve the structuring of the lesson's content and the students to identify the subsections and key concepts. Okay, so let's start with the structural feedback. Because it is much more straightforward. So in order to provide structural feedback, the robot started at the beginning of the lesson to introduce the lesson by recapitulating the previous lesson, which could have been 1 week before, and by giving an overview of the ongoing lesson. During the lesson, the robot gave reminders to the professor, to the teacher, for example, to do breaks. These reminders were set to the teacher herself in the beginning of the, or before the lesson started, so she could decide when the robot would make these interventions. And it was doing so by basically raising his arms, waving, to create a reaction in the professor, and then saying, you have spoken for so and so many minutes. It might be beneficial to have a short break for the students in order to respect the biological rhythm of the learning cycle. We administered also a questionnaire towards the end of each lesson about what was taught in the lesson. And immediately after this questionnaire, the robot would give a general feedback to the students, but I will explain this in a second a bit more. And towards the end of the lesson, the robot would give a summary of the ongoing lesson and ask if the students have further questions for the teacher. And then there could be a discussion. Okay. The provision of feedback about the progress of the learning cycle had two aspects. The first aspect is the modeling of the reflective processes of the students. What we mean by this, in order for the robot to do this, the robot asks questions about the key concepts introduced by the professor during the lecture. The questions are asked in such a way that they might represent doubts the students could have about the content of the class. In other words, the robot asks questions the students have, but are not aware of that they have it until the robot asks them. So this happens frequently and unexpectedly during the lesson. So the robot would ask, for example, if the lessons would be about what is knowledge, the robot could ask something like, how can knowledge be put into perspective and be contextualized? And so the students would think, oh, I'm not sure about what knowledge means, but the robot asks something I'm not clear about. So this initiates the cognitive conflict and then the ability to reflect about the problem. That is the first aspect. The second aspect of the provision of feedback about the progress of the learning cycle concerns different types of feedback. This is more direct. So we have basically an immediate general feedback that the robot gives during the lesson after the questionnaire I mentioned before. So the students know in general in the entire class how well they understood certain concepts and where the problems are. We have personalized feedback where the student can give his or her ID to the robot, and then the robot would give a specific feedback in the breaks or after the lecture. And we have a detailed personalized feedback where the robot could give feedback about open questions that were asked in the questionnaire before. Also based on the ID of the student. So this is a quick flow chart, how we implemented this. Basically, in order for the robot to be able to give the feedback, we used it in combination with an audience response system. In our case, it was Google Forms. And basically, you see here on the slide, the robot would stand in front of the class in a standby mode. Then the student could go up, touch the head or the hand of the robot, and then the robot would ask for the ID. The student would give the ID. The client, which means the computer in the robot, would send this ID to a server, which is a local computer, and then this local computer would connect to the audience response system, in our case, Google Forms, search for the entry of the student there, do some calculations, and then send the calculations of the data of the students back to the server. Then the server connected to the robot, and then the robot exhibits the response behavior, which means gives the personal feedback to the student. Okay, this is an example of general feedback the robot gave in front of the class. So directly after the question, the general questionnaire was administered.
è stato dato la risposta esatta da giudice verso Rossi. È stato dato la risposta esatta
You can see here the very positive reactions of the students towards this feedback, basically because they see, oh, we understood this specific key concept, only 22% of us understood this. So, which means maybe there's a problem and maybe we need to focus on the next lesson more on this specific concept. This initiation of the positive feedback makes us believe this is also something that can be used specifically in educational children-robot interaction. Okay, now just I need to speed up a bit. Let's briefly move on to how we evaluated this long-term study. So basically, at the end of the lecture, which lasted 15 individual 3-hour sessions, we administered a questionnaire, a final questionnaire, which was composed of open questions which allowed the students to share their thoughts and opinions about the interventions of the robot freely. And from our 163 students, we got 155 replies, of which 152 were positive. Only one was negative, saying that the robot was disturbing, and 2 were productive criticisms. Of the 152 positive replies, 36 replied something like, I like the robot, which has not it's positive, but it doesn't have very much information content. That left us with 116 positive answers for categorization and in-depth analysis. We were able to structure the answers of the students into 5 categories. And since the students were allowed to answer freely, some of the questions concerning the usefulness of the robot were relatively long and included various points. So we therefore included some of the answers in more than one category. But in general, they could be summed up into first category, the robot helped me with self-reflection, which is very interesting and fits our ideas about what the robot could do. Secondly, the robot helped to understand specific concepts better, which is probably due to the way the questions were asked and due to the feedback the gift concerning the questionnaire. Of course, the robot helped with structuring the lessons. This is a quite obvious one. Then the robot promoted the active role of the students, which was very interesting because due to the discussions initiated by the robots, the students could talk amongst themselves about key concepts or even ask the teacher they didn't understand. And very interesting also is that they identified, that some of the students identified with the robot. They saw it like another student. So they didn't see it actually as a tool or as a teacher, but as one of them, so to say. So undeniably, the robot had effects on the teacher and on the students. For the teacher, basically, the benefits were that the teacher obtained an overview of the level of the created knowledge in the students in real time and in long term. The teacher can have a discourse about this level of knowledge with the students during the lecture initiated by the robot. The robot catches and maintains the attention of the students, which is also very important because in a 3-hour lecture, it can get quite demanding for the students. And the teacher can structure the lecture better, enabling the robot by enabling the robot to give naturalistic reminders. But of course, this also creates some demands in the teacher. So the teacher needs to think before the lesson how to structure the lesson. And also needs to reflect about the cognitive status of the students in order to predict what the questions of the student might be. So in order for the robot to ask. And these questions need to be phrased in such a way that the students can identify with them. The effects of the positive effects of the robot for the students are that the robot helps them to clarify the roadmap of the lecture. that the questions of the robot and the real-time feedback help the students to understand their own doubts better, and that the question of the robot help to activate the cognitive conflict in the students that connects the students' knowledge with the new problem and the related new knowledge. And that the interventions of the robot promote an active role of the students and encourages them to discuss critical topics amongst each other and with the teacher. In conclusion, it can be said that the multimodal use of humanoid robots as social mediators has the potential to strengthen the reticular nature of the teaching process and to facilitate the creation of new knowledge. We think that further exploration at the university level of our approach is needed, but basically we wanted to present this work here in order to showcase the approach and to discuss possible applications for educational child-robot interaction, because I think there's a lot of potential there. Thank you very much.
Grazie. Se ci sono domande da parte dei partecipanti.
C'è una domanda.
Sì,
In chat.
Okay. Una domanda in inglese, quindi la pongo in inglese. Did you detect the risk that the robot's intervention tends to replace or anticipate the question the students would ask?
Sorry, you're
Hagen, il
muted.
microfono.
Okay. Can you hear me?
Yes.
Okay. So on the contrary, it seemed to us that the robot would ask questions the students were not aware of. So what the students told us was, oh, I was not clear about this concept, but when the robot asked the questions, I became aware that I was not clear of that concept. So it would not actually replace the questions, but initiate a self-reflection process in the students. Because instead of passively following along the lecture and consuming the knowledge or the content that was given by the teacher, the questions, the interventions of the robot, also because they were not in sequence, they were not at fixed points. The students became more actively involved and questioned their own perspective on a certain topic. So the robot was not replacing a question, but basically posing a question had but were not aware of, according to the feedback we got from the students.
Altre domande? Abbiamo ancora spazio per una domanda o due. Altro aspetto, ne faccio una veloce io ad Hagen, e cioè se il robot Pepper aveva dell'autonomia o se tutto il suo comportamento era in qualche modo già preordinato. Did the robot have any degree of autonomy or was everything scripted?
Was more or less semi. So it was not scripted in the sense that everything happened on a fixed point. But the robot, we would have key phrases that would activate the robot, or the robot was activated via touch sensors. So basically, the robot was standing in front of the class, and while the teacher was giving the lecture, moving around, the teacher could go and the robot touch the robot on the head or on the hand, and that would activate the behavior in the robot. Autonomy. This is exactly the crucial point, and this is what I meant. That's why I started with the theoretical background. This is actually one of the issues we still have, is the appropriate reaction towards human behavior in this kind of robots, which would mean autonomy. Because specifically in the classroom, which is a noisy environment, not only acoustically but also visually, it is very difficult to have the robot to work completely autonomous. So it's better to have it in a semi-autonomous, also scripted mode. And Pepper allows for this.
Grazie. Chiederei a Matteo Torri di prepararsi per il prossimo intervento.
Grazie mille. Arrivederci.
Thank you.
Grazie.